AI in Action is brought to you by Alldus International, covering your business's staffing, consulting, and networking needs. Our host, Mark Kelly, brings you the leading minds in AI, sharing their story, their success, and their advice. Focusing on fast-tracking you to the top, AI in Action cuts through the hype to help you kickstart your data science career. To listen to the latest AI in Action podcast, head over to www.alldus.com/podcast or subscribe via iTunes, Stitcher, or Google Podcasts.
Welcome to the AI in Action podcast. I'm your host, Mark Kelly. My guest today is Hamid Nawab. Hamid is the co-founder of a company called Yobe Inc technology, and Hamid is an MIT PhD researcher focused on applying AI to signal processing. Hamid, you're very, very welcome to the show.
Yes, hi Mark. I'm glad to be here.
So when you think about Yobe Inc, you should think about signal processing. And what does that mean basically?
So signal processing that thinks is really meant to address what's known as the cocktail party problem. So the cocktail party problem is something that many of your listeners would be very familiar with, in the sense that if you've ever been at a cocktail party or any other public place where there are other people talking, there may be music in the background. And in that environment, what you want to do is pick out an individual voice. You want to listen to a specific person. We as people are very good at doing that. And if your listeners have any experience with various speech recognition systems on their smartphones, for example, or their smart speakers, those are not very good at being able to follow individual voices. And so signal processing that thinks is a concept that we've developed, and algorithms that we've developed using AI and what is known as signal processing to get those parts of the sound signal that correspond to individual voices and separate them from each other.
Okay, so we've all had that issue. We might necessarily know about that issue, but we're able to, as human beings, being able to decipher. I think that comes back to when we're kind of young kids, and even within the womb, we can actually listen to our mother. From all the different millions of voices that are out there, we can actually pinpoint that. So when we come out, we actually know who our mother is as well. So it's actually a fascinating subject. So what kind of inspired you to kind of go and solve that problem? And just for our listeners to know, Hamid would be regarded as a world-class researcher from his experience in the background. So actually, it might be an idea, Hamid, to give us a little bit of your background before you got involved in this company.
Yes. So I started out working in the signal processing area as a graduate student, and I did my PhD in signal processing applied to voice signals. But signal processing is basically a mathematical approach to getting the relevant information out of a sound signal, for example. When you're trying to do that, the problem is that the strictly mathematical approach doesn't always work. And so after I finished my PhD, I started working at MIT's Lincoln Laboratory. And one of the assignments I had back then was to look into artificial intelligence and to see what artificial intelligence, which was relatively in its infancy back then, if there were any areas of intersection between signal processing and artificial intelligence. And so since the 1980s through the 1990s, in the last 30, 35 years, I've been constantly working in areas that apply signal processing combined with the smarts, if you will, of artificial intelligence, including machine learning, to coming up with novel solutions for problems in which either sounds or other kinds of physical phenomena are interfering with each other. So, for example, I've also applied this in the past in my academic career to separating signals that control our muscles, brain signals that control our muscles. And one of the things we'd like to be able to do is measure those signals from the surface of the skin above any particular muscle. At least that's what neurophysiologists like to do. But their problem is that all the neurons that are talking, if you will, are talking simultaneously. And they were very interested in being able to separate those. And the solutions back then were not very successful. They could separate maybe a few the neurons talking, but that was about it. But in my research through 2010 or so, showed that you could actually separate as many as 50 or more neurons talking at the same time. And that really led me to think that this is a technology that I've sort of bumped into that combines signal processing with artificial intelligence to separate complicated signals that are mixed with each other. And so that's where I was academically. And that's when I ran into my co-founder, Ken Sutton, who was at that time very interested in the fact that one of the solutions he presented to me was one in which music could actually be improved. Even though the amount of storage that is used to store it is reduced, its quality could be improved. So he was looking for somebody like that. He had some connections with Boston University, and a friend of mine actually at Boston University, a colleague, he was able to get in touch with me, and we started a collaboration. We started looking at what we could do, whether we could automate that particular solution that Ken had. That solution involved using studio equipment to make music signals sound better. But it was an empirical method, and a human could do it. But the question was, could software automatically do it?
Which is
and
so
where we started looking for how to automate making music sound better. But then we realized, we sort of pivoted to voice, that we could make voice sound better, and in fact get rid of background noise, including other voices.
Yes, which is really, really important. And voice recognition technology is already such a big part of our lives, but there's still some issues with it. What advice would you give to people working in this space to try to improve on this and make the most of their product? And maybe some of the challenges that you've had to overcome with your own product?
Right. Well, I think, speech recognition as well as voice recognition, or what is called speaker recognition, basic technologies for that do quite well, even today. However, the problem is when you have the speaker in the far field, that is, a person is speaking, let's say a distance of 6 feet or more from the microphones, what is technically called being in the far field, it becomes much more difficult for current state-of-the-art technology to work well. So we call this the far field problem, for both speech recognition as well as for voice recognition or speaker identification. And that is an area that people have been trying to address for a while, and this is exactly where Yobe technology is most relevant right now. And what we bring to the table is the fact that we not only use machine learning, but we use something called abductive reasoning. Abductive reasoning is, if you will, what a detective does. A detective is able to look at the evidence, and based on the evidence, like footprints, things that have been broken in a room that's been broken into, the detective is able to sort of reconstruct what might have happened when somebody broke into, let's say, your house. And so the action of a detective, what a detective does, is exactly abductive reasoning. And it is that capability of abductive reasoning that Yobe brings into the solution to the cocktail party problem. So it allows us to combine power of abductive reasoning from artificial intelligence with machine learning from artificial intelligence to control the mathematical algorithms of signal processing. So signal processing is quite powerful. It does a lot of things. It can analyze the signal that comes into your microphone that is noisy. It's able to separate the noise. However, in doing so, it needs some intelligence to be able to deal with the kinds of changes that take place in a normal everyday environment. So people come and go, television may be turned on or turned off, a music be played or not played. So as things change, the signal processing has to intelligently adapt to the situation.
And evolve. Hamid, for the novice listening, what is the benefits of your product then? What are the other kind of products out there? Maybe kind of three to four benefits that could be fairly succinct.
I think that in terms of the benefits, first of all, if you think about your smart speaker, and if you tell your smart speaker to play some music, and if the music is playing and you try to talk to your smart speaker, it can't listen to you. That kind of problem does not really make a smart speaker very smart.
Correct.
Secondly, the smart speaker cannot generally recognize who you are, particularly if it is noisy. And what we provide is the capability that your smart speaker will be able to not only recognize you, but recognize you even if there are other people around talking, or the television is on, or there's music in the background. It will be able to recognize your voice. And by recognizing your voice, it'll be able to pull up your profile so that it will know what, for example, what kind of music you like to have played, or what your calendar is. And if you want to know something about your calendar, it will be able to answer that. So profile retrieval based upon identifying you as the owner of that device is a very powerful use.
Hamid, I think it's a very important point because there's still a lot of friction there. It's not frictionless at the moment. I've got two young kids. We're using Alexa to play different music. I want the music. My son wants the music. It doesn't pick up children's voices that well. It's inconsistent. There's no context. There's loads of different things with that. So we would have kind of hoped in some ways we're further ahead, but again, it's narrow AI. It's very specific on what it's working for as well. So for users that are listening in at the moment, they've got an idea of what you're doing. So you're concerned with how signal processing that thinks, you're solving the cocktail party problem, and you've kind of clarified the solution. Tell me a little bit about what the impact that you could have with maybe two microphones and kind of generating better results in that.
Yeah, one of the facets of a really interesting facet of our technology is that it can work with as few as two microphones, although it can use more. But what we have found is that even with two microphones, with the right kind of abductive reasoning, machine learning combination with advanced signal processing, we can do a much better job than, for example, devices that are currently available, like smart speakers that have several microphones, like 7 microphones. Because in those other solutions that are currently available, they apply only signal processing principles by and large. They're relying mostly upon the mathematically based algorithms of signal processing. Now, some have also tried to apply machine learning, and that has its own disadvantages in the sense that in the audio domain, for speech recognition or for voice recognition, you really have to train the solutions for a variety of different situations and for different environments where there's different degrees of reverberation. So for example, I'm sitting in a room right now which has windows on all sides, and the sound echoes a lot, as opposed to if I were in a big hall or if I were outside. The reverberation characteristics or the echoing characteristics are very different. Our technology does not require it to be trained for all those different environments. You can enroll somebody. That's the technical term, enroll, when you're teaching the device your own voice. With just a few words, you can, in any kind of environment, as long as it's not noisy, you can train it. And after that, using abductive reasoning, the device is able to recognize you even in noisy environments and environments that have different degrees of echoing or reverberation.
Hamid, where do you see machine learning / AI going in the next year to 3 years? I'd be scared to ask you 5 years because it's so hard to tell with that question. And even if you told me the answer, I wouldn't believe you. So where do you see it?
I think, to me personally, the most important impact of AI in the next 3 to 5 years is in terms of making interactions between people and machines more natural, whether it's in terms of voice or visually, so that one does not have to face the problem where the device trains the person rather than the person having the device learn exactly how the person does things. And so artificial intelligence will make machines more natural partners. And as part of the Internet of Things, which I think is going to become more and more important. And I think in the next 2 to 3 years, voice is an important part of that. Because while we have voice recognition, speech recognition working quite well, it only works in those limited situations. So you have to adapt to the machine rather than the machine adapting. That's a problem that in the next 3 to 5 years will be quite successfully addressed, in part by Yobe, and I'm sure other companies are making their efforts in this.
And Hamid, I think it's something that's so important, because if you look at your phone today, and I've got one in my hand, there's not much real estate for people to be able to type. It's a very clunky process. You're going to pick an item, even if it's on an app, it's a clunky process. When kids are 3 or 4 years of age, they're naturally speaking and engaging. They're using Alexa, no issue whatsoever in terms of just quickly picking it up. And we're tapping and stuff like that. There's definitely kind of an evolution here that's going to start to make it easier to interact with all devices. Your TV, for example, play the soccer match between Man United or Arsenal through voice rather than clicking through 100 channels, which is a lot of friction with that. So I think it's really, really set up for this disruption. Hamid, thank you very much for your time today. I really, really appreciate it.
It's a real pleasure.
AI in Action is brought to you by Alldus International, covering your business's staffing, consulting, and networking needs. Alldus offer an exec search program. Alldus can help you discover how data science and AI can transform your company. With our unrivaled network of C-suite executives and senior AI professionals, we offer retained search services across the US and Europe. For more information, contact mark@alldus.com. Get the Alldus advantage. Become a member of the Alldus community and enjoy some of the following: AI meetups. Once a month, our community gathers to listen to some of the leading experts in the world of data science and AI. Our speakers come from all over the world, including Dublin, Boston, and Frankfurt. We also have our AI mentors. Our experts will provide mentoring to Alldus members. And don't forget our AI in Action podcast. Each week we have guests from all over the world talking us through their education, career, and more. Become an Alldus member and get the Alldus advantage. For more information and to sign up for our newsletter, log on to www.alldus.com. That's www.alldus.com. Alldus International, empowering through AI.